Good afternoon, everybody. Welcome back to lecture number 25. Today we will review the last time we started talking about the braking. صح ولا لا?
صح.
And does the braking means reduction in speed all the time in machines? No. There is 4 types we are electrically braking. For instance, it will come in the major two. Okay? List all the situations where the braking is electric. The first one is rapid stopping. You move from speed N1 to speed N2, where N2 has to be 0. Second application, holding the rotor shaft at a specific position. This means you stop the shaft and you apply a positive or negative torque, like holding the elevator. This is also braking. Maintaining a motor speed at a desired value. ثبت السرعة. For electric vehicles, it is like holding the shaft, holding the constant torque. Preventing it from increasing or decreasing requires braking, electrical braking. Why electrical braking is important? So let's call it electrical braking. It's better than mechanical braking. All these aspects are done electrically without physical pads applied on the load, without physical friction. The mechanical load during the braking, it becomes a source of energy. And that's why we want accurate and fast braking methods, okay? There are 3 different types of braking. We have regenerative braking, we have dynamic braking, we have current braking, also HEFL. Now there is no way, you have to study. Now if you want to include them in the formula sheet, I don't care, you can include them, okay? So you have to collaborate in your formula sheet to make it more يعني, comprehensive.
Victor, if you include them in the formula sheet, you will not bring them as a question.
Okay, that's one trick to avoid difficult things. Regenerative braking. What is the regenerative braking? Now let me ask you an example. This is very important, and remember this. Drive 2 cars, one electric, one hybrid. Who has a hybrid? None? You have a hybrid.
My brother.
So take your car and your brother's car and do this experiment. In the hybrid vehicle, go downhill. حطها على N. Will you see regenerative braking?
ما أتوقع.
خذ السيارة البنزين العادية وحطها على N والسيارة تنزل. Would you consume gasoline?
No.
So in either cases you will not consume gasoline. But if you drive EV, if you put it in the N, you will not have regenerative braking. Regenerative braking means in your car you will find the flow of energy goes from the tires to the IM. This is regenerative braking. Okay? Or it goes to the battery. Okay? In regenerative braking, the load, which is the tires, send energy from the tires to the induction machine or to the battery. Most likely, since the induction machine is already going downhill, the induction machine will do regenerative braking. Will send both of them, the tire. No, not the tire. The tire doesn't communicate with the battery. The tire will power the IM and it will send power. Okay? Forget about this. إذا حطيتها على ال N, if you put it in the N, you will not have regenerative braking. Clear? Try this experiment. Okay? السيارة العادية, if you want to save fuel, you put it على ال N when you don't need gas. Okay, those who drive with low mileage cars, they understand what I'm talking about.
يعني عشان شغل الجنريتور اضغط بريك.
No, you have to put it in the D, in the drive mode, to enable a regenerative braking. Regenerative braking, if you're going down the hill, the electric vehicle or hybrid electric vehicle will send electricity, will recharge the battery. It's the only time where your hybrid vehicle or battery that it's going to be charged while driving, okay? Okay? Let's keep it simple and relate this one. Okay? Now, if you're going uphill, your battery should send power to the induction motor. Okay? Try this experiment, okay? Now, electric motor is in regenerative braking when the load torque reverses its direction. Now, what is the direction of the torque here? The torque, if the car is going uphill, the torque is pushing the car clockwise. صح ولا لا؟ الجاذبية تسحب الأرض على تحت. فالtorque will be counterclockwise. If the car is going down, what is the torque? Going to the right direction. So at this point, the load torque reverses its direction from counterclockwise to clockwise. So is this a constant torque?
No.
No. It's a torque that varies with the speed. Is it active or reversible load torque? Yes. Is it dynamic? هل هو ديناميكي هذا اللود؟ Think with me. Is it dynamic?
ما مقصود dynamic.
Dynamic, it means it is capable of changing its torque depending on the speed. So now, or depending on the position of your trajectory. Is it dynamic?
Yes. Yes.
So now, because it's dynamic, we can have a negative load torque. But what is the direction of the speed of the car? The car is going uphill, so omega is counterclockwise. The car is going downhill, omega is what? Also clockwise. You see it? So here we have torque that is positive, here torque is negative. Omega is positive, omega is
Positive.
still positive. So torque times omega, where torque is negative, this is a negative power here, this is a positive power here. I'm teaching you physics 101. Understand? But they didn't tell you regenerative braking. They give you all the nonsense. Okay? Causes the machine to run at speed higher than no load. So do you think the speed here is faster than here?
Okay.
It is faster here. So here we're exceeding the synchronous speed, here we're below the synchronous speed. So this is higher than the synchronous speed for the induction machine. So this trolley bus in uphill direction is working in the motoring mode to drive the bus with the torque in the same direction of the speed. The motor itself, now the load torque is counterclockwise, صح? To overcome it, we have to apply the motor torque clockwise in the direction of the speed. صح ولا لا?
Yes.
Now when you go downhill, what will happen? When the trolley is moving downhill, the torque direction will be reversed and the power will be transferred from the load. Now, will I apply a torque by the machine or will the load apply torque in the machine at this time?
The load.
The load will apply. The controller, there is no point of putting a torque, that's opposite. So now we are in the generator mode, okay? So now we in the regenerative mode. It's a generation, but it's called regenerative braking, okay? Now why we call it braking? Because we cannot, if we apply the same torque, same as the load, our speed will go and become unstable. So we're braking, we're maintaining a speed that is omega. And we are using the flow of energy back to the battery. Is it clear, the regenerative braking? Who doesn't understand? Any question on this slide? This is again the power flow direction. Here is the load torque. Here is the machine torque. Here is the omega. If you reverse the direction, the load torque will go up. Now, are you familiar with the Newton's third law? The machine itself would counter that load also. But because of this counter, magnetic flux will be generated, okay? It is always lower. Clear? Now, here is a question. What if I want to change the speed and I don't have an active load? Torque is reversed and speed is not. That's the previous example. The power flow is reversed. Two different operations for second quadrant. We have two different operations. One with active load, one without active load. This is with the active load. We're starting at speed 1. Okay? Here I make the torque negative, but my speed is the same. Do you see it? This is uphill, this is downhill. Speed is the same, roughly, it's omega, but T1 is positive, T2 is what? Negative. Did I need to apply any control on the machine? Or the machine itself went to the regenerative braking mode? The machine went from motoring mode to point number 2. What is point number 2? Regenerative braking, because it's an active load. Let's say you have a unidirectional load torque. This unidirectional load does not change its torque when I change the position or when things change. What will happen?
When you change the position,
Yes.
higher speed.
Immediate control.
Remember, in the previous example, omega here is same as omega here. We're applying motor control.
So,
Otherwise, we will have omega here faster, which is nonsense. You need to have motor speed control, or at least within a margin.
Doctor, what do you mean by the load is that active?
طيب, active load معناته active load. طيب, do you remember active source في الباور? Active source or passive, active or passive? Active means it's dynamic. It changes based on the energy. Here the mechanical energy is different than the kinetic energy here is different than the kinetic energy here. So the torque direction for load means the car. The torque that the machine sees by the tires or by the car. Here the torque is جاذبية من هنا, صح? فالتورك is in clockwise. Here الجاذبية من هنا. فالتورك is what? Counterclockwise. Your machine has to accelerate here and decelerate here or brake here. صح? Look at this figure. We're applying opposite torque from the machine. At this side, going uphill, the power flow is positive, so we're sending the power from the motor to the load. For downhill, we're sending the power from what? The load to the motor, because this load, TL, changes its direction. One time it's negative, one time it's positive. في الuphill كانت counterclockwise. في الdownhill صار اللود لا clockwise مع عقارب الساعة ضد عقارب الساعة. This is what we call an active load. When you plot it in the curve, you cannot have it constant torque, 150 Newton. This is the active load, okay? This is the passive load or unidirectional. Unidirectional and it doesn't have negative torque, okay? If you want to apply regenerative braking during speed control for the non-active or unidirectional load torque, like constant, it doesn't change. For example, the elevator, is the load always down, up, pointing downwards or upward?
Up or down?
No. نفس اللود. الفورسز حقت اللود.
Down.
The three body diagram. Always down. It does. الاليفيتر ما حيطلع فوق وينزل تحت. It's always down. Now, if you want to push it down, you go in the favor of it. If you wanted to pull it up, you apply opposite torque. هذا على الموتور side. So I can say it's a unidirectional. Unidirectional. It's not active. Okay? So when you apply, for example, an elevator unidirectional, you apply speed control. You want, for example, to reduce the speed of the elevator. You want to reduce the speed of the elevator a little bit. You go from F1 to V1, you apply V over F, you apply on this curve V3 and frequency 3. But can you jump in the speed directly? Or we have to go gradual?
Of course you have to go gradual.
You have to go gradual. It's a mechanical thing. There is no way. You have to have an acceleration. Cannot jump from speed 0 to speed 10. You have to go through speeds 1, 2, 3, even with microseconds. What is happening here is you go from point 1 to point 2. Okay? You cannot go to the same point here because you will never ever be able to reach the same curve. لأننا عندنا active load, unidirectional load. Previously you can go on the same curve from 1 to 2, صح? For a unidirectional curve, you cannot go to point 2 here. Why? For simple reason. You cannot have negative torque. Remember, هي شوي صعبة عارف. In this figure, we have point 1. Here we have point 1. هنا عندي في السيارة تطلع فوق تنزل تحت. Can I go to point 2? Yes, because the load T2 ينتمي إلى الرينج حق TL. صح ولا لا؟ Think with me. في السيارة لما تطلع على فوق تنزل تحت، لما تنزل على تحت suddenly التورك بيصير negative. What is my operating point here? هي ال cross section between the load torque wal capability torque. I'm not drawing the motor torque هنا, it's complicated. بس إن أنا أعرف إن at point 2 is applicable because I'm gonna experience negative torque. So I can run my machine on this curve. But if I have a unidirectional torque, I am not allowed to operate, to go through this speed, through this torque, if I want to have regenerative braking. So what is my only solution is I have to change V over F, meaning I have to change the synchronous speed. I have to change all my capability curve, and then I will find another intersection here that drives me back to point number 3. So during the transient of time, remember this will take very quick time, I will experience a little bit of regenerative braking. Even though the torque load is not negative, the fact that I'm changing the V over F to another curve, I have to experience, apply a negative torque, and then suddenly go back to 3, and then I will reduce the speed. For this minor braking will be regenerative braking. Remember, it will not settle here. It will go all the way here. If I change V over F, suddenly I'm going to operate here. We will have opposite torques between the load and the motor, and then it will drive myself back to stability at 3. So this is only transient. This is transient regenerative braking.
يعني في الأكتيف steady state يعتبر.
Yes. So if active is a steady state, it will stay here. For transient, if I apply V over F, I'm going to experience minor regenerative braking. Do I love it? Yes. Because it saves my mechanical pads and it generates power. Think about it. Does it make sense?
لأن الريجنريتيف بريكنج هيكون التورك والسبيد different size.
Yes. Because you're reducing your synchronous speed. لما يصير بيصير كأن الموتر اللود أسرع من الموتر. فلما يصير اللود أسرع من الموتر بيصير نيجاتيف تورك. صعبة صح؟
ما أنا تفكيري.
Think now. It's time to think. Sam.
ضد صوت ما عاد في.
I'm not going to ask a question about this game in the test. Okay? But I'm going to ask questions about this game. الفكرة من هذا الكيرف إن you apply voltage, you change the voltage, you change the F. So your torque will be reduced. So now your load is applying higher torque على الموtor. Get it? It will have a transient time until the load slows down, and then it will catch the motor. Then that torque will be positive. It has to do with Newton's third law. You push the table pushes me back. But this is only transient. This could be only 1 second. Because زي القصور الذاتي, okay? Think about it. When you apply V over F, you're going to have moment of inertia. Okay? This is the magic of transient regenerative braking. The other option is the steady state, which we covered before. Okay?
دكتور في مثال الإليفيتر الريجنريتيف بريكنج يكون يعني لما يوقف الإليفيتر أو
When you check the speed and change the voltage and you want your elevator to slow down, for example, before it reaches the destination, it has to slow down. Think about the towers elevators. They start fast and then they slow down. The moment they slow down, it's regenerative braking.
بس التورك لسه بوزيتيف أصلا.
I know, but this is transient.
What's the point of regenerative braking if you are connecting to the grid or giving back to the grid?
Well, you're using the magnetic flux brake instead of mechanical. This is benefit 1. Benefit two, because of this electrical braking, you give back to the grid. Yeah, you save energy. Over time, it accumulates. Okay, clear? So when you apply V over F, you're gonna have regenerative braking during speed control. Remember, here you have speed control. Here you do not have speed control. You're maintaining the speed. Okay, next lecture we'll talk about the induction generator. It's hard.
والله بدي أشد الكورس.
Yes, it's hard, I know. So let's look at this example. So I'm gonna, because this is deep technical, I'm gonna solve this easy example now. We will go back later to the wind. This is a simple example. 208, 6-pole, 3-phase motor, R1, R2 equivalent are given. motor loaded by 30 Newton meter bi-directional constant torque. So this is the car is going up is 30. The moment it goes down, it applies negative 30 on the load. It reverses the direction. If the load torque is reversed, calculate the motor speed. Apply the negative torque. Use the approximation. Here there is no 3, so we use line to line. Is there a 3 here? No. So we use 208 squared times S times omega S, which is 2 pi alpha 200 على 60, because synchro speed for 6 pole is 1200, times R2 prime, which is 0.4, and you get the slip, which is what? Negative. What region we are? We are in the regenerative braking. So the speed of the machine is 1242 RPM, is higher than the 1200. So now we are in the induction generation mode, okay? Is it clear? Easy, صح? The only trick is you have to apply minus 30. Why? Because the torque load is reversed. It's reversed now. Calculate the power delivered to the battery of the electric vehicle or to the supply. How to calculate the battery? To calculate the electric power, we need to subtract the winding losses from the developed power. So what is the developed power? Is converted power. Your question, Osama asked me on Teams, he said there is a mistake in one of the slides. When we talk about the maximum torque, we do not look at converted, we look at the air gap power.
بس كان الغلطة إنه هو كان بيستخدم السينكرون سبيد، أنا كنت قايل إنه هو بيستخدم سينكرون.
I know, the formula.
المفروض إنه بيستخدم السبيد العادية.
لا. P converted versus P gap. All of them, they have the same torque, but one has omega M, one has omega S. So when they talk about full load,
يكون
max, they use this. They don't count, because here they don't want to calculate the I square, the copper losses. It's the same. I would accept both.
ChatGPT قال لي العكس والله.
No, don't look at ChatGPT. 360, the books, they usually omega S for sizing the machine. Okay,
طيب.
get it? Very close numbers, ما حتفرق واجد.
أيوه.
So ما تفرق كثير, but use omega S. So here we use omega, not S. We use the omega of the actual motor, because we are calculating the converted. So here we have 30 Newton. Then you have apply that. You can apply negative sign here, but you will confuse yourself. Then what is P converted? Another formula is 3I2 square R2 over S times 1 minus S. Why we use this formula? To calculate the current. When I calculate the current, I'm going to calculate the copper losses. I'm going to subtract it from this. Then I can calculate the power. So if I solve for I will be 10.5 amp. Remember here we have negative sign indicating that the current is giving power, is reversing its direction. But because this is an I squared, you pick positive or negative. You can pick the negative, but the power here is negative, so it means I is in the negative direction of the power. Then power losses is 3I2 square R1 plus R2. You sum all the R's in the equivalent circuit, which is 330 watt. You subtract 330 from 3902, and this is the power that is delivered to your battery during the regenerative braking. So this is a good power. And this is the whole concept of hybrid EVs. Hybrid EVs, they only charge during the regenerative braking. There is a plug-in hybrid, which is a mix between EV and hybrid, but which is more expensive. But most cars here in the kingdom that have some batteries, they are hybrid. And they only charge their cars during the regenerative braking, which is roughly 3 kilowatts every time. So next lecture, time is up. Next lecture we will go back to the wind turbine, which is an important application in real life. what is inside the wind farms. Then we will talk about dynamic braking and counter current braking. Okay? So remember, regenerative braking occurs where? Two instants. Instant one, active loads, active or bi-directional torque loads, like the car, for example. Or two, transient with unidirectional torque or load only during the V over F control for a short period of time. Okay? Which one gives you more power? Of course, this one. Clear?
Yeah.
This one is hard. I'm gonna only ask you about the text. I'm not gonna ask you about the drawings. Okay? It's only what you need to know. It's called transient regenerative braking on unidirectional loads. It exists. Okay? Thank you so much.
تبدو وراك ولا نخليك؟